So if you don't have a chapter in your community, get in touch. We'd love to help you set one up. Also, check out if your college or university already has a student club. If not, love to help you get one started. Obviously, join the Slack if you can, and there's a link on the meetup agenda. You can check out Learn Neurotech, neurotechedu.com for the online educational platform, and sign up for our newsletter. Check out the job boards at NTX Services. All right. And I am having Jitsi problems myself. Anyway, great. Happy Thanksgiving, everyone. And we will we'll be having a presentation today from Omar Al-Hashmi. And we will also be talking about all the week's events and symposia, and obviously planning for next week's brain hack and associated events. Also, Montreal Mind. Sorry, Maine Mind. I was thinking of another project. The Montreal AI and Neuroscience meeting, and then after, following that is the Neural IPS. So we usually also start with just giving anybody who's first time here a chance to introduce yourself and tell us what brings you here. It is not a requirement. Okay, please. Yeah.
Yeah. A few people heard this earlier, but my name's Elizabeth. I'm right now applying. I'm in the middle of the interview process for a neuroethicist position on a BCI team in the Bay Area. But I'm joining you guys from Colorado. My background is clinical ethics, and I used to be a broadcast journalist. So that's kind of a crazy road that led me here, and I found you on Twitter. So.
Okay. Oh, terrific. That's when you were searching for something on Twitter, or?
Yeah. I was looking. I realized I didn't really have a strong foundation of where like the technology is, so I was trying to find articles on like BCI and what's current and what's being researched. And yeah, I think I searched BCI, neuroethics, neuroscience. I was just like scrolling through, like mining Twitter, and found this. So.
No, good. Well, great to have you here. And yeah, is there anybody else that's new this week?
Yes, it's me.
Please.
Yes, Caroline. I was just looking through Meetup, and I thought the title is really interesting, so I just want to check out the group. I'm in the business development, and I provide technology solutions in the cloud computing and cybersecurity. And
Okay.
I always look out for something interesting. So this looked really interesting to me. So I just want to learn a little bit more about the group.
Sure. Great to have you both. And yeah, we've got a few kind of set things that we're going to talk about at the beginning here, but please ask questions too. If there's things that you want to know, or things that don't make sense that we're talking about, it's actually just as useful for us. And yeah, so let's see, it's 6:15, or yeah. But John, tell us just a little bit about. I want to talk about the NeurotechX events, and of course the big thing next week is Brain Hack Global.
Yes, happy to do that. So this is something that we've mentioned a few times over the last few weeks, but we can mention again that I think it's the 1st to the 12th or the 1st to the 14th of December is like the window of Brain Hack Global, and there are actually sounds like some kind of new people on the call, so I'll say a little bit what BrainHack is. BrainHack's like BrainHacks are basically mini workshops, or a combination, an intentional kind of fusion of a short workshop and a hackathon or a sprint, where the aim is to get people together working on short, kind of small, mostly coding oriented projects, and facilitate discussion, generally do some coding together, but also talk and exchange ideas and skills and so on. So that's like the broad overview. And that this thing kind of started about 5 years ago, and it just blew up. So over the last few years, it's evolved into this somewhat international phenomenon where, on this occasion, this BrainHack 2020, there's going to be, during that window of 12 days or so, probably about 30 events worldwide, mostly about 2 to 3 days. And each of those has their own program and their own kind of focus according to the people who are organizing it. So that's kind of BrainHack in a nutshell. Definitely the thing to do is to click on a few links, do a bit of Googling. Hopefully some links will pop in the chat. Yeah, thank you, Morgan. And you can kind of fill yourself in a little bit more on that. But in addition to that overview, what we're doing specifically is during the 2nd to the 4th of December. And so I'm in Toronto, and us in Toronto and some of the people in Ontario are doing one of these events. And as part of that, but not kind of tied to Ontario per se, because we're trying to do this in a kind of global way, bringing in people from whoever wants to chip in from wherever they are in whatever time zone. But during the period that we're doing our one, the 2nd to the 4th, we're also doing a sprint, a coding sprint, basically, on this project that a few of us in this group have been contributing to and talking a lot about over the last few months and years, called EEG Notebooks, which is a kind of modest software library for doing, say, cognitive neuroscience and BCI experiments with mobile EEG devices. We can, again, we can put some links in, and I can give you a primer on that project in general, but I won't go into that too much here because we talk about it quite regularly on this call. But the key message here for the update wise is really firstly, I think I've said every week for the last 3 or 4 weeks, it's like, yes, I will get this organized, and I will post a link, and I will put it on the official projects board and so on. I've done it. It's there. Can we get a link, Morgan?
Yeah.
I want to put a link in it. I'm gonna pull up a link right now. But if you look on the projects list, it's there. I've done it. I mean,
it is, and I
modest, hour of my life.
So I'm just looking for the sign up link.
Are you saying in the all the major work that you've been anticipating for the last couple of months, or what?
Yeah, Richard.
Is it in like a stable state, you would say now?
I think stable enough. It's a good question. It's stable enough. I mean, there's certainly like we're anticipating, operating system specific bugs to come up in installations and so on. And we're trying to kind of, as we cast the net wider, we will get more and more like exotic errors here and there. But this is like the reason why I did this little tweet thread. And one of the things I mentioned on this thread was that, and this was the intention, was that we're kind of opening up to the world officially on this event, in the sense that the group of us who've been doing some fairly regular development on this project, we've been putting in a fair bit of effort on it particularly over the past few months, but also like 1+ years. and in my case, maybe 4 years. And it's been not on the down low, but we haven't been kind of shouting from the rooftops about it, because we've been trying to get it to a point where we can say, okay, this is stable and kind of usable to the somewhat general user, and we've more or less reached that point now. So this is the beginning of a bit of a kind of public-facing push, let's say, in addition to trying to bring in collaborators and new people and new ideas and so on. So that's what we're aiming for with our project that's running during BrainHack. You know, there are going to be a million other projects running during BrainHack. That's kind of the whole point. Yeah, great. So we got some links going into the text there. Did you put the one that's the actual project on the?
I put the actual project website.
Yeah, you did great.
BrainHack Ontario as well.
Yeah, and perfect. Okay, so there's multiple links in the chat there that people can follow up while they're not listening to me continue to talk, or not listening to the next person continue to talk. But final parting words is we would love to hear from you. We're really happy to talk to everyone and bring in everyone, whatever their interest and expertise level is. If there's a route to, you know, useful discussions and kind of mutually beneficial work on this project. There are a lot of different things that we're interested in doing, some of which is really in the weeds, kind of IO, even hardware coding. Some of it is really more like trying to describe brain science to a general audience. We're trying to do a little bit of that as well in the documentation around the tool as well. And that's something that we're looking for people to contribute on as well. And you don't need to be a coder or an engineer to be able to explain how the visual system works, for example. So there's lots of opportunity for people to actually make valuable contributions at various levels. And if you're interested, then just reach out. We'll be looking forward to hearing from you.
Yeah, awesome. And yeah, we're definitely, I've been trying to talk to different groups that use BrainFlow, or that are now in the EEG notebook supported device group, so that we can, even if it's just collecting ERP data sets with this, with the paradigms that we've got enabled. Certainly still been talking to people about, just adding PsychoPy experiments. And a lot of good discussions. In particular, like I said, I spoke to, it's Jason Fauquier. Jaden would know. He works at Mind Effect. And like I said, like really interesting in terms of, like they're going to be very compatible with the EEG notebooks because they're using BrainFlow as well. So hopefully they're trying to do an event in, so like I said, there's a lot of NeurotechX events coming up next week. So Amsterdam is going to have its first meeting. And so Mind Effect, which is a BCI company that started as a Kickstarter project. And I don't think Jaden's on. So I think Jaden was working with their original equipment, which I think, Richard, am I right that they were using an OpenBCI amp, but a kind of like wet electrode? I don't know if Richard's, but
sorry, I just stepped out. I was trying to make some coffee. What?
Oh, no problem.
I think they were using Ganglion for some stuff. Mind Effect.
I feel like Mind Effect, the original project, was using an OpenBCI
headband.
Yeah, but then they were using like their own electrodes and headband.
That's all I knew.
Okay, but I think it was like a ganglion.
I just thought it was cool that they had made their own little device and they had some basic processing on the Raspberry Pi, which is
right.
Because I want to see like concerts and things like that where people on their like they say, okay, you can use my data for this concert, and they don't store it or anything. But it needs to be cheaper and it needs to be smaller to that point because nobody wants these VR rigs with a backpack. I saw that from HP from the rig that was talking about.
A lot of the original Moby Lab stuff is biosemi in a backpack, and let me.
Is that just to gather the signals?
Yeah, Jason Farquhar. Well, that's just so that they can, it's the mobile lab. So it's so that they're not tethered to a computer and they can walk around in a room. And, in the case of San Diego, they're in this like huge space. It's like the entire it's the entire ground floor of the supercomputing center. It's just this massive room. So, people can, if you check SCCN Moby Lab, you can see pictures of them, or I'm pretty sure you can see pictures of the space. And again, like that was, original motivation for Christian Kota to write Lab Streaming Layer and get all those, get those all those wearable streams that couldn't use triggers and other traditional means to synchronize clocks.
Did they make the software themselves to synchronize?
Yeah, and I want to say Christian was the original author, but it might have
that software.
What's that?
What are they doing with that software currently?
Well, so it's really taken on a life of its own, right? So back in it's like,
is it just called Moby Lab?
7? Well, so I think Christian came out of the Berlin Moby Lab. If I'm right, there was a German one before San Diego, and I think he was starting to write it there, or like it could have come out of that lab, but he was definitely like a principal. But then in like 2012 or 2014 or something, Brain Products actually hired someone, hired one of the Lab Streaming Layer, maybe one of Scott's grad students or postdocs that was really familiar with Lab Streaming Layer and like built Lab Streaming Layer into all of Brain Products software too. So then it kind of like got adopted by, Brain Products is a pretty big player in the research market, right? And like I said, I've said this before, like Chad Boulay, who maintains the Lab Streaming Layer GitHub, is does a really remarkable job. There's definitely some other people, like this T Center. I only know people's GitHub's usernames, but did the wheels for the Pi LSL. Chad's had help, but he's he replies to so many questions on Slack, and so I think it's been adopted by a lot of different groups, and as was GazLab and what is now Neuroscape, where we were putting it into PsychoPi quite early, and Did Omar? Did you have you were using NeuroRacer?
Yeah, I basically developed NeuroRacer.
Right.
Yeah.
And were you doing? You didn't need. Did you need events like Lab Streaming Layer, or you could use triggers?
Yeah, we always used diode triggers on the screen with photodiodes, and then for that from RiScanner we used serial triggers.
Sure. Sure.
Yeah.
Serial boards.
I think it was like Jackie doing maybe some of the first like neuroelectric support where, like using wireless headsets.
Yeah, I didn't get into the LSL stuff until a few years after I left Adam's lab. So like for more personal projects, but
Sure.
yeah, I don't know. Does the BrainFlow libraries, are they reliant on LSL or they're their own thing?
No.
People from the get-go, like even before we were done before we did the first public facing BrainFlow, they were like, "Oh, I want to use the old OpenBCI LSLs," and we're like, "Please don't use that."
Yeah, I wasted a month trying to use them too. Yeah.
But now we don't have an official. It probably needs to be in the docs, but yeah, you just get data from BrainFlow and then use whatever LSL wants you to do. It's easy peasy.
Yeah. So
You can do it all in Python.
Andre Parfenov, who's the BrainFlow developer, joins us at NeurotechX Paris on Mondays, and we've talked about this before. Like again, he doesn't really see the need for LSL, but as like but you're not trying to gather 4 wireless streams, like 4 Bluetooth devices or something. He's used to like just having direct access to the hardware.
I'll say what he would say here is, BrainFlow has something called streaming board, and you can stream to a file or you can stream via USB port, and it's if you don't need a GUI, it'll get it done.
Yeah. So
sorry not to dwell on this, but so does it actually synchronize with other devices or no?
What, BrainFlow?
Yeah, like it's sort of a yes or no.
If
Does it actually do it?
LSL
No. Okay.
But then LSL would handle that, we're not.
This is
Like
again
because
No. I've messed around with stuff enough. I know what a headache it is.
we don't
try to
actually send the
stream.
timestamps from the sites on. I mean, I think somebody tried at some point, but really we just say we know BrainFlow received a packet at this time, and that's it's pretty close.
Cool.
Well,
I think you'd have to ask him in the BrainFlow Slack.
let me.
That's a great place to ask him about it, though.
Okay.
I don't know how you find that, but go like BrainFlow Slack, and then it automates an email to ask him to let you join or something.
Okay. Cool.
Yep.
Oh yeah, I can send you an invite.
Oh, that'd be cool.
Yeah.
There are technical questions like that, and he's happy to answer them.
Yeah, I mean, he's a terrific programmer and really knows his stuff. So yeah, this week has also been NeurotechX Barcelona, doing a couple events related to architecture and design. I don't know if anybody's caught those. I couldn't do the Saturday, but I did send for us a paper. So Carl Friston seems to have a paper on everything at this point, and so like 2 weeks ago, Friston released a paper on architecture. So
yeah, I sent that to a student of mine who's interested in architecture.
Okay, well, I sent
I don't
it.
know if you read it, but
I sent it to Faraz, who's the chapter lead in Barcelona, who's put together this Neurotech design group, and he immediately was like, "Oh yeah, I know the first author." I'm pretty sure, yeah. It was also funny that this week Carl spoke at the Santa Fe Institute, and the title of Carl's talk was "Me and My Markov Blanket," which, yeah. He had some good physics papers though the last couple of weeks. I don't know if you saw those, John.
There's one that's it's like particles and something. Is that the one you're thinking of?
No,
that went up
it's like a Lagrangian formulation of DCM.
Right. Yeah, I saw that one and I haven't read it yet. It's impossible to read all of the things, but I saw it. But the particles one we're taking a close look at.
Is that good? Yeah. Okay.
It's kind of, it's about parcellation. It's about like thinking about brain parcellations from the point of view of, from the point of view of kind of, if you had a system, a brain that has multiple kind of independent interacting components, what would it look like versus if you had a system that are a certain size versus you had a system that had multiple interacting components at a different size, and what if you took the one that had multiple components that are of this size and you chopped them up into smaller pieces, what would the kind of hierarchical relationship look like? That's the gist of that one. So it's kind of Markov blankets meets brain parcellations. It's very niche, but it's pretty cool.
Did he do that with somebody, from brain parcellation, with brain parcellation history, or no?
I'm not sure actually. It's an extension of the resting state DCM stuff. Actually, it's like Adil Razi and Joshua Kahan. They've had a couple of things on that line. There are some other people on there who might be, but it's not a kind of completely different crowd. Like, it's really an extension of what they've been doing so far.
Gotcha. Well, I just also wanted to say, NeurotechX Paris next week is we're going to have Mental Lab come and talk. This is Sebastian Herberger from Berlin, and they've got their own device, another wireless system that we'll hear about, and then the end of next week is Zurich is having another meetup on neuroethics. And so you can get all these links on the meetup agenda. In addition, if you scroll down, there's the December 2nd meeting on neuroethics meeting. I think there's a film for anybody who's interested in such things. Did I put that link in? Oh yeah, they're screening I Am Human. And I put IEEE Brain and International Neuroethics Society is co-hosting a meeting, and you can sign up for the Zoom. Anyway, so I want to switch over and introduce our speaker for this evening, who's lovely to join us on Thanksgiving. And yeah, Omar, can you give us a little? I know you did at the beginning, but give us again just a bit of your background and.
That was actually my entire plan, because I wasn't sure the format of this thing. So I'm just basically gonna. I guess I'm some kind of a first timer too. I'm gonna basically introduce myself, what I've done, and then I actually had a few questions for you guys. Awesome. So let me. I don't know. Can you guys read it's showing up on Jitsi, right?
Yeah. You can make that full screen.
Yeah, make it full screen.
Oh, will it work?
Yeah.
Okay.
It is this funny thing where it's like when you share your screen, you get 3 tabs, and so you can choose a screen, or you can even choose like an application, or you can choose a Chrome tab. I don't know if you see that.
Oh. But no. It's in PowerPoint, right? Oh, I see.
You can select PowerPoint.
Okay, hold on, give me a second.
No. I'm sorry. Everybody has a little Jitsi learning curve here.
Yeah, this is the application one, which is what I had, and then.
Oh, okay. Did that not? Okay.
I'm looking at Chrome tab. I don't see that as an option though, right?
So I do present and then select this, and select the screen.
Oh yeah, the problem is I have like an ultra wide screen, so.
Okay.
Yeah.
Oh, okay.
No worries. I can read it.
I can read it. Oh, there it goes.
Does that help?
No, it's doing something weird.
Yeah, you're right.
That's an ultra wide for you.
Learning new things.
we
Oh,
can,
yeah.
we can read that.
All right. Well, let's stick with this one then. Okay, cool. Let me turn my camera back on. Okay, cool. Yeah. So that was my plan. Yeah. Thanks to everybody joining me on Thanksgiving. Yeah. So I guess I actually just to kind of cue you guys, some of the questions or maybe quick discussion topics I had for you is you guys were talking about it. I actually looked at the EG notebooks this week. A quick question for you guys actually was whether you can do live data on that yet, like streaming, so you could do metrics. It didn't look like it to me by glancing at it, but
Yeah, it's a very good question, and the answer you're correct is no. And
okay.
it's not something that we are against, but it's not. It's also same time it's not the kind of focus of the project. The focus is really at this point anyway. It's more around a kind of standard offline cog neurosci experiment
Totally makes
epoch
sense.
design and so on.
But
I think there's potentially like a kind of convergence between these two. Like, you'd like to be able to do, for example, like an online updating. I could imagine, updating an M&E epochs object real time, for example, and generating a real time updating ERP. There's various things that spring to mind, but they would all be like somewhat ambitious at this point because it's not something that we have much infrastructure around.
Yeah. So like, so the thing that I guess brought me to the meeting is I threw up a video. Morgan somehow within 24 hours found it and doxed me. Thanks, man. Yeah. So
Morgan sees everything. Morgan sees and knows everything.
Yeah. It was quite intimidating. So he asked me to do this, and I agreed because I didn't know what else he could do. So no, I'm kidding.
Thank you. Thank you.
Yeah. So, but in order to just throw that together, it was kind of a silly project, but it was kind of a pain to get all the like live stuff working. I had to, use. It's just technical details, but I used like async and a bunch of stuff that was kind of annoying to work with. But anyway, and then just the other two, which are probably lengthier and maybe for a different meetup at some point. I just think it's interesting to wonder, what your guys' perception who work with this stuff, the actual single trial accuracy of the neurotechnology at this point. I've done a bunch of projects and I kind of cyclically get frustrated with this stuff because once I work with it, it usually is pretty low if it's not a trivial kind of stimulus or feature, like you're trying to do like an oddball or something. And then just kind of whatever your guys' sense of that is, it'd be kind of cool to get. And then I know you guys had or at least were scheduled to meet with a guy from Kernel.
Ago. We had a request that we not record that. So it was so you might have seen the beginning of sorry that we posted it. We posted it and we had the YouTube stream and everything, but once we started talking, there was a request that that not be recorded. So
that makes sense. I actually so
he spilled beans about everything in the company. Everything.
Yeah, it's interesting because I guess this is being recorded, right? So we can't really reshare this.
It's okay. He also caught our initial meeting where we actually just talked about their announcements, and so we've already dealt with that embarrassment that they heard us.
Yeah, man. It's like it's more than once now. Someone said, "Oh, I saw that discussion you guys had." And I think like these evening discussions we have are so informal, and we were a bit what do you say uninhibited in a few of our critiques of Kernel during that discussion, and then it turns out the Kernel guys have been watching it.
And I had like 1,000 questions which were answered by the video in the next day.
Yeah.
Oh, well, I see. Yeah.
There was that
data breakdown, and I had all these. I was like, "How do you fit the lasers in there? How powerful are they?" And that came out in a detailed video.
That was actually part of the reason that he got in touch. He was just like, "You need to check out this other video because that will answer a bunch of your questions."
Okay, that's cool.
but we can definitely answer more questions about, or like I'd love to know what your questions are, and I'd love to get your opinion of what it could be used for, or like
Yeah.
what would be markets for such a device, given the fact that I'm sure you understand pretty well what the limitations are of even their NIRS device, in terms of like it's not going to get deep sources. It's still going to have some issues with hair, even though it sounds like they've really done some remarkable engineering for a number of the kind of standard problems with NIRS, but at the same time, like they're not going to solve depth, and and it's still not really clear what their software stack is in terms of how they are merging together the kind of like necessary, Monte Carlo depth understanding together with the kind of temporal physiological, denoising and estimation of underlying neural sources.
Yeah. So my background, obviously, I don't. I mean, Morgan, but yeah, I do EEG and fMRI, or I used to rather, but yeah, I don't have much experience with FNIRS, but so I don't know what the stack is just to get like the images they're seeing. But once you get to that point, which I assume they'll have, combining the two types of information that headset collects, I can imagine some sort of competitive advantages, because you have one that's kind of spatial, one that's kind of temporal, and
you're thinking of them combining the OPMs with the NIRS.
Well, wasn't there their announcement? Yeah, their announcement has EEG channels on it.
Oh, yeah. So they have 8 EEG channels.
Right.
And they're kind of yeah. So
yeah,
we definitely asked a lot about that, and yeah.
I think that really does seem like one of the most interesting things about high definition FNAs in general, but their device as well, is the fact that ideally it can kind of slip in and replace EEG fMRI, or at least complement EEG fMRI, which is not easy to do, right? Even when you have all the gear and the millions of dollars that it costs to do that, you spend years denoising the data. Yeah.
Are you talking about the FNIRS or also the EEG?
No, I was talking about EEG, concurrent EEG fMRI, right? So that's that's in some respects that's kind of a gold standard in the sense of multimodal brain, non-invasive brain measurements, right? But it's hard, right? It's harder than just straight up fMRI, considerably harder. That's why people don't do it very much. So
But
the fact that there's scope for doing the FNIRS equivalent of concurrent EEG fMRI, that seems to me like one of the biggest strengths of that technology.
But is there? I'm not following. Is there a crosstalk interference from those two modalities that you have to worry about or something? Because like fMRI EEG is a way big of a hassle, right?
Yeah, that's what. No, that you can do them concurrently. Yeah, so exactly. They have onboard EEG sensors, and they don't have them particularly high density, but I think in principle they could do with a different design.
Yep.
And there's no kind of particular technical issues with that. I mean, you can even do brain stimulation with FNIRS without major artifacts, which is another feature of that kind of multimodal option.
Yeah, so I don't know if anybody else is interested, but they obviously have an application window open right now where they're so I might take a stab at that, but
awesome. Awesome.
Yeah, I've got one. It's going in the next few days. It's been doing the rounds of the collaborators, but
oh, cool.
It's a bit dense.
Yeah.
Got like a million things in it.
Let's let you finish up, but and then we'll come back to kernel ideas.
Okay. Yeah. So, like I said, I thought of just I'm gonna kind of walk through what I've done because I guess it's kind of I'm just kind of to some extent introducing myself, and then also if anything in particular is of interest or helpful to you guys or anybody individually, or you have any questions, I could talk about that. I didn't know about the exact constraints on the time of this meeting, so I initially was gonna hard exit at 7, but I can exit at 7:30.
That's awesome. That's why I try to get us started early.
On your thing, because it clips your camera clips out the bottom.
Oh, thanks, man. Let me zoom out. I was trying to fix it.
There you go. That's fine. Oh, nope. One more.
Let me shift it over.
There you go. That's fine.
That's
Okay.
awesome.
Okay, guys. Yeah, so I'm just gonna keep this list kind of up, and if anybody's super interested in any of these projects, I have all the PowerPoint slides from over the years open, so I can probably pop something open really fast. But yeah, so I actually met Morgan. I guess served together in Adam's lab, right? 2010, 2014. That's UCSF. So I actually did a lot of the development work for NeuroRacer, which I don't know if you guys are familiar with. It's just a multitasking driving game. My PhD thesis was so I've always been kind of interested in cognitive performance in general. My PhD thesis was focused on multitasking in that lab. Technically, it was also an aging lab, so we looked at a lot of like effects of aging, which is kind of interesting because you can, with multitasking, with a sensitive enough, I guess, test, you can start to see aging effects as early as 24 years old with multitasking. Like people kind of peak out and then start declining at that point. Which I always thought made sense because if you look at like professional video game players and stuff, they kind of tend to taper off at that age too. So anyway, I did everything from behavioral work, EEG, fMRI, and then I also did combined EEG fMRI, which was kind of a nightmare project that I don't think I went anywhere. But so I have the paper. Well, there was a Nature paper. It was published on the cover of Nature. That was a remediation of the elderly using NeuroRacer and EEG. And that was in 2013. There was a paper that Morgan posted. That was a Cortex paper. That was an fMRI paper. That's pretty straightforward. I used the different conditions of NeuroRacer to isolate what I thought was a multitasking, an area related to multitasking in the brain, which was the right superior lobule in my case. And I've seen a few. ResearchGate is great because once you get away from research, you can still, it's like Facebook, you can see people trickling in and referencing your stuff like years after the fact. You finally get, anybody going through a PhD, it takes a few years before anybody, affirms your work. But anyway, and then there was another paper that is just sitting on archive somewhere, which was an EEG paper I did with very precise timings and ERPs using NeuroRacer, and that was more visual attention, looking at P100s. So yeah, that's kind of my background. And then I also did a lot of the design work and early research on Achille Interactive, which just this year got FDA approval for pre-adolescent ADHD. Achille Interactive was spun out based on the NeuroRacer work out of UCSF. And yeah, they're like funded at $160 million. They got FDA approval, and they're continuing to try to bring that to the clinic. And then after all that, I went to UCLA. I worked on a couple postdoc projects. I had DARPA funding and NIH funding for a couple different projects. The DARPA project was this memory and virtual reality project, which I can talk about more if you're interested. And then the NIH project was looking at like neuroactive drugs, like actually mostly nicotine, actually, but we looked at like modafinil and other ones like that too. Okay. And so that was all fMRI work, both of those projects. And that's where I got really into MVPA analysis, if you guys are familiar, multivariate pattern analysis, which I think is could be particularly helpful if you're trying to go across modalities like kernels. So anyway, and then I left academics after that. So and then since then I've been kind of just to make money. I've been doing private industry consulting. So I've worked on with companies that work with cognitive training and mindfulness apps, and trying to get FDA approval on apps. I guess also another area I've worked on is like game design work using psychometrics and adaptivity, because a lot of the like the NeuroRacer and Achilles stuff used a lot of that. And then something else I was trying to list out, what else I've done. This stuff isn't really neurotech, so I didn't know how interesting it was. But yeah, and then I also had a paper in CogSci this year on cognitive metrics. I guess that was multitasking related again. So, and then another thing I did was worked at a. Oh, sorry, somebody asking a question. Sorry, my audio.
Well,
really...
sorry, that was me, Omar. I was just gonna say, I think those are neurotech things. I mean, I say this a lot, and I remember us talking about certainly psychometrics, and what you can get from diffusion drift models and things like that, of just reaction times.
Actually, it was a conversation with you. I remember. I think you're the one who introduced me to the idea of X Gaussian taus, which is what I ended up using for the paper, and we ended up using for the Achilles stuff too.
Okay.
So and for you, those of you who aren't familiar, it's like if you take a Gaussian model and you convolve it with an exponential, and then you get a Gaussian with a tail. And so for reaction time, it's kind of interesting because sort of your median reaction time sort of correlates with your neuronal speed, or at least some people, it seems to kind of fit. And then the tail kind of correlates with your sort of distractibility, or how much attention you're paying, or how much, sort of your attentional lapses. So that's all behavioral data without any neurotech that,
I think the our computational behavioral science like still makes it seem when you're still trying to link it to particular neural responses, or these at least constructs that we have that psychologists use. I still it's not, you're right, it's not like measuring something physiological.
It is technology sort of measuring.
That's
it could be neurotech.
That's what I still.
Yeah, but if you broaden that definition enough, your Apple Watch or your smartphone's neurotech too. So,
well,
maybe
I'll tell you about a group that's trying to do stuff with that. But when you say cognitive metrics, what I mean, because those sound.
That was actually it was X Gaussian taus reaction time. It literally was. So in that case, I can give you the one sentence on that paper. It was if you have people play. So in this case, I actually used the Lumosity data set. They have like 50,000 participants playing 100 sessions. So I was able to take metrics of how they played, say, the first like 5 sessions, and then predict in 100 sessions, where they'd be at, like how much training gains, things like that. And that was, and the metric that ended up being sensitive, that was X Gaussian tau, which is what the paper kind of focused on. And then the other thing, I guess, that might be of interest. I used to actually work at a venture capital firm for like 3 years, but that was mostly biotech, life sciences stuff. I don't know. Part of my intro, I threw that in there, and then that's it. And then on the side, I've been doing kind of some small research projects. I got some DARPA and Army ARL funding for some stuff on the side. But yeah, that's basically what I've been up to. So.
When you say FDA approval, like how do you get involved in something like that, or like what aspect do they bring you in for?
I guess there's a lot of layers to it, because I actually don't know. I'm not super up to date on all the nuts and bolts of the actual pathway approval. They have like de novo pathways, they have 501(k) pathways. It's more like pre-FDA on the science side of the clinical efficacy of what they would need to show to the FDA, and then executing those studies successfully. So yeah, it's stuff like that. That's awesome. Yeah, I don't know if I can, especially with the we're recording this, so I could tell you offline maybe,
No,
but
no,
yeah.
no. That's
Yeah.
yeah. I mean, we do. Yeah, people have shown us stuff, and then we've had to remove it.
No, I won't. I'll keep.
Yeah,
I'll try
that's
to
cool.
yeah, show some self-control. So,
But that's interesting. And then can you say something about like how game designers might care about psychometrics and building what would they want to build into their game?
yeah, that's a good question. Let me see if I can find it. I think actually, I was gonna do a GDC talk, and then they
Cool.
totally canceled it. But
Oh,
let me see.
I mean, does so like
I can give you a one sentence answer. I was just seeing if I could pull up a slide that would explain it really fast. Yeah,
that's awesome. I mean, like SIGGRAPH has some really hardcore physics and math talks and workshops associated with it. Does GDC have anything equivalent? I mean, on the kind of
sometimes. Definitely let us know if you're going to try doing the GDC talk next time it actually happens in person. Like, I'd love to go to that. I've gone to GDC past 5 years, and yeah, I definitely love when they have more like experimental and like things outside of typical gaming stuff. Like, in 2019, they had quite a few talks from Xbox about their adaptive controller, which is a custom buildable controller for people with disabilities. And those talks were amazing. But there's rarely any BCI related talks or things like NeuroRacer being talked about at GDC all that much. So I'm very sad you didn't get to present this year. I hope you get invited back next year.
Yeah, I guess I don't. I guess this presentation is kind of long, so but I can give you the one sentence. I guess there's a lot of overlap between the idea is there's a lot of overlap between scientific assessment and things that game designers or other people maybe trying to design like training programs or something. Game designers and trainers are both interested in engagement, and so scientific assessment has this. Morgan's familiar. All the psychometrics that involve discerning these like sigmoidal S-shaped curves like they do for hearing famously from the 1950s where this stuff started. And it's kind of interesting because there's a lot of like overlap with people's cycle of engagement where they kind of stair step and you kind of have to put them right in the middle of this challenge zone so that where they're not too bored and they're not too overwhelmed. And so kind of finding them, and it's kind of a sort of sigmoidal shape too. So there's a lot of overlap there. And then on top of it, if you're trying to train somebody, that's probably the optimal place for them to be to learn or work out or whatever they're doing. So that's kind of the concept. I think that's like the biggest concept probably and how those things overlap. And then the idea is like, how do you do that in practice? And obviously that's depending on what you're trying to do. So that's, I used to be really interested in that stuff and talk more about it. I kind of was looking at my old presentation. I was like, oh yeah, but I don't really have any. These are all kind of very non-technical slides. I'm looking at them now, but
sure.
But yeah.
Can I ask then a bit about the neural enhancement? Oh,
yeah.
Good slides.
Yeah. I was So I mean, because like it's kind of interesting. I'll just add one last thing on this. Is like let me see if I can find it really fast. Because like in a lot of modern games too, there's sort of almost psychometric type or what do you call it? Like ELOs, like rank placement, depending on your ability level. And so there's a lot of I thought I had the slide somewhere.
Can I ask you-
Oh yeah, right here. Yeah. So the idea is like, you know, you're kind of stair stepping up, and so, you know, oh, you know, I'm not sure I'm going to be able to summarize this quickly. Yeah. So I think it's interesting because ELO systems kind of have this. They have their own like requirements or goals, and then the game designers are also that interaction happens a lot where game designers and the ELO people are working, and it's kind of interesting because as you get higher in the staircase of rank or ELO, you have less people that are better than you, and you have a lot more people that are worse than you. But that kind of works out because people, you know, can enjoy having a few easy games against people that are might be a little worse than them, and then having a challenging game against people who are better than them. So they get really into the details in a lot of these gaming companies about that stuff, about the experience side, and then the actual like ranking ELO advancement. And then I was saying, and then there's like the third sphere, which is the assessments, which you get into like the psychometrics and what information you get when you challenge somebody with somebody easier than them and somebody harder than them. So that's just kind of a whole little area I'm interested in.
Hey, Omar, I have a real general question on that before we move on.
Yeah, go ahead, fire.
How many papers, how much research is being done on like item 6, sub-bullet 2, game design, psychometrics? But what you just described, how many papers are published each year on that, you think?
Oh boy, I actually don't know. I have no idea.
Not many.
Yeah. I don't believe so, because the last time I was really into the literature was when I was in my PhD. So I probably haven't visited this stuff since 2013, maybe, or 14. And that was all very like there's a lot of stuff in different psychometric algorithms. And the funny thing is, I designed all the NeuroRacer and Achille algorithms without knowing the literature at all. You know, I just kept trying things until it worked. So. But they have all these like Bayesian psychometrics and stuff like that. But there's once you cross over into like the video game industry or some industry that's trying to use this stuff, they're not aware of anything technical like that, you know. I think they got sometimes hire PhDs to do the rank systems, but they end up modifying it so much based on like feedback and experience that they don't really.
So, do you think there's more private knowledge on game design and psychometrics than public knowledge right now?
I think I think that's a good.
Oh goodness.
There's a lot. Like I know people at Blizzard, League, the people, and a couple other places who they definitely have psychometrics for analyzing how to give rewards and all this stuff and change stuff so that they can either make stuff more rewarding or harder. And generally a lot of places keep it very close to themselves. There aren't many public talks at like GDC, and I've noticed, at least in terms of literature, there's only 1 or 2 good papers every year that actually are like referenced research, while a lot are like thesis papers about theoretically this is how people would respond to these types of game designs.
That's what Omar was doing. He said he would predict their outcomes of that data set, right? With just a few games.
Oh, that. Okay, let me use my awesome
predicting user behavior.
Yeah, that's this paper, but this paper is way more scientific. It's not very. I mean, I think they were building. Oh, is it working?
No.
It's so weird.
There you go.
No, it's not. I dragged a PDF, but okay.
So yeah, if you try to bring something else in, you're gonna have to like exactly, and then reselect.
There it goes.
Yeah.
Yeah. Josh B says
we're not happy with everything about Jitsi.
Okay. Yeah, this is the paper, by the way. It was in Cognitive Science Proceedings, I think, and it was this. I mean, I think they were possibly going to implement a machine learning model on their side, but I don't think they ended up doing that. Where's the punchline here? Oh yeah, here it is. This is, yeah, I don't know if you can see this. Oh yeah, I can zoom. Hold on. Yeah, so the idea is that the sort of the gains people got on the Lumosity platform in this particular game, which was Highway Hazards, if you're familiar, they there was a strong correlation with this metric from their early sessions. So the gains overall, you know, and so this is very much more sciencey finding. I don't know if it's very you know, it's not like League of Legends or these other big video game companies. I would reinforce everything that I sorry, I don't know your name. What was the guy who was just talking?
Ryan.
Me? I'm Ryan.
Ryan, yeah. I would reinforce everything he said. I would say that my experience has been exactly what he said, and that people who are in this industry often too, the problem is a lot of these game designers that are more senior, they treat it more like a art than a science. So it's like they have a feel for what's, you know. So but when they describe it after time, oh yeah, I have to the switching thing is kind of annoying. Sorry, hold on. Give me a second.
Yeah, sorry.
Okay, but yeah, you know, this is sort of a model in some of the game designers' heads. You know, they have this idea of like, rising action, climax, and then falling, and there's a resolution, and you know, like storytellers have the same. A lot of things kind of follow this, but it's sort of just like a model of human engagement, and I think they just have a much more intuitive feel of it. So anyway, let me switch back to the grand list here. Oh. That doesn't work. Okay.
Yeah. That when I saw that slide, I was like, "Hey, I remember teaching that. I helped teach game dev at City College of San Francisco, and we used very similar graphs and stuff where you actually can zoom in to, or not really zoom in, but look at that at different levels. Like each chapter of a game has that exact same diagram, and then the overall game has that diagram, and like pretty much it keeps breaking it down into more discrete versions of the same graph, pretty much for basic forms of engagement. And then there's always visual game design, which they've actually started doing a lot more scientifically, especially in VR. There are ways in VR to do gaze tracking to see how well people can follow paths or find objects of interest and use that to figure out what to change to make people more engaged. They don't do big studies on it. They're literally just like changing the color or size of an object till someone can easily find it. They aren't trying to do like double blind studies of, is this color better for a hammer?
Yeah, it's a lot of like almost user interface domain stuff. So
yeah, I was going to say that one of the research areas that I think you can actually find a lot more is what is sometimes just called CHI, or like certainly
HCI.
HCI, yeah. I mean, depending on the conference.
yeah.
And but yeah, like without it necessarily being games, it's a lot of the same kinds of problems.
I know like in near SF they have the NASA Ames Center, which used to do a lot of that stuff. They have a division on Microsoft Research that does a lot of that stuff. Yeah,
and one of the super interesting comments, or like I forget what the Microsoft developer conference called. Is it just called Develop?
I have no idea.
Anyway, but like their annual conference. Chris Bishop is now their head of machine learning, right? And he said that the biggest problem they have is like kind of assigning people levels and kind of, you know, staircasing people in you know, for Xbox games.
Yeah, well, a lot of problems too. Like there, I mean, if they really get in this topic, I mean, like what's also interesting is they like accuracy is not the highest necessarily goal of theirs too, because you need to combine that so that the user has this experience of progress. And you can kind of dissociate that sometimes with different score and reinforcement award systems and things like that.
Yeah.
And
Yeah.
and same thing with cognitive training. You know, it's the same issue. But yeah, I mean, we used to, I don't know if you went to any of those conferences, Morgan, but back in 2012, I believe there was kind of a peak in neuro gaming. There was like a hype. It's so funny because when I searched that stuff on YouTube, like
It's
they're
called
all
Peak, right?
what peak?
Was it called Peak?
Oh, the neuro gaming conferences.
Yeah. What was the neuro gaming conference called?
The one I remember going to was SCons.
SCons. Okay.
Yeah.
No. I mean, I didn't catch those.
Okay.
Yeah.
Anyway, yeah. So anyway, that's something I worked at a while. Yeah. Thanks, Ryan. Yeah, and some of those talks I have is because I was talking to game engineers and game designers, like a games team, and they have these ways of thinking about things in terms of integrated game loops, which are all, you know, smaller temporal to larger temporal scale reinforcement cycles, basically. And I was like, oh, that those kind of lend itself to integrating like assessments and stuff too. But anyway, yeah, that's I think I covered everything pretty much. So that's the list. I can go back to the questions if you don't, or if you anybody else.
I would just love to know what you're doing with nicotine.
Oh, nicotine.
Yeah,
I can talk about that for a second. That was 2015.
Yeah.
How was it delivered?
Smoking cigarettes.
Seriously?
Yeah.
I thought you were gonna like let them drink something or injections. No.
Yeah.
It's gross.
No. We had to. I mean,
We
we had a
smoking area outside the lab. Are you let them?
No, we had a room in the basement somewhere at UCLA. Yeah. So we had it was actually an intense amount of data collection because this was within person 8 scans, and these scans were like 3 hours long.
Wow.
So we had it was blinded where they would smoke a cigarette with no nicotine and then various doses up until like a full dose. So it was, and then on top of it for the IRB and like all that stuff, we had to use smokers, people that already smoked. Right. And these are all young people who smoke quite a bit. And so the effect of them, I don't know, like I'm sure their tolerance level is really high. And then we're having them not smoke, come in, you know, smoke. They had such negative things to say about these research cigarettes, you know. But that was a cool project.
Oh wait, that had to be a control in the experiment. They couldn't bring in their own brand.
No. That actually that one of the days they did do that.
I guess you could poll them and get the average. No, that's not going to work either.
But there was actually 10 sessions because one of the days was come in, get scanned, take a smoke of your own cigarette, and then scan them again. So. Yeah, the two big findings of that, and I never published that one, but because that's when I left and I was totally over academics. But that was one was being able to quantify the dose in the brain of like sub single cigarette amount of nicotine, and I used MVPA to do that. So that was really cool. And then the other one was to get sort of a hierarchy of effects or influences on the visual cortex of drugs, in this case nicotine, kind of what they were looking at, the salience of what they were looking at, and there was a third feature.
So there was a visual task.
Oh, and there was an instructional set. Yeah, so it was a visual task.
Like a spatial attention thing where they were responding, or just perceptual.
Wow, you're really growing me here.
Oh wow. Well, I'm curious. What were they?
No. I can remember.
Under neuro enhancement. I'm just curious.
Go ahead.
I feel like the nicotine would change more of the behavior of like if you're done eye tracking, you'd see more jumps or something.
Well, we weren't recording.
You were actually trying to see what's coming in off the eye, and then what we can pick up residually.
Yeah. And actually, so nicotine's really interesting. I didn't know anything about nicotine. I wasn't terribly interested in nicotine, but it was it combined a lot of other things I was interested. So, but it's actually really interesting. Or I found it more interesting once I looked into it because it has a pretty profound effect on the visual cortex pretty widely. There's the nicotinic. So that was another cool thing is when I did MVPA on the full brain, it matched up with the nicotinic receptor location as they found in like histology and stuff in the brains. So it has a pretty widespread. Let me kill this list because I don't know if you guys.
How long after were the scans done? 10 minutes?
Yeah, that was another problem is that they're smoking cigarettes sometimes that it's like a tenth of a dose of a cigarette, and then it would take like 10 or 20 minutes to get in the scanner.
They could smoke like, I don't know, but
like 20.
Like the effects, I think, kind of like with stimulus and Adderall, it ends up the peak gets smaller, and then the tail it dips faster.
Yeah, I thought it was a disaster of a design, but I got the data and I was able to find something.
Cigarette might only.
That's a lot of scans.
It was a lot of scans, and it probably there's probably other interesting things.
Of scans to not think about their design so thoroughly, or like.
Yeah, there's a lot of I don't know. I don't know if it's UCLA specific, but there's a lot of NIH connected labs that are just raking in the cash and not thinking too much. It was already ongoing when I got there, and I was like, oh well, there's a lot of data here, and we certainly can do something with it. And the other paper I was working on, I wasn't a lead on this, but I was but this was a project I had suggested because I was like, you guys are scanning so much, you should do a reliability study because this is all within person. It's crazy, and they're coming in at 8 a.m. for 5 scans, and then they're getting scanned again at noon, for 5 scans. So, I think I left when that was all ongoing. But
I would think the biggest change happens right when they smoke the cigarette. If we're talking A/B testing with an fMRI scan, like the 5 seconds before and 5 seconds right after, I think you're going to see a huge.
Well, we weren't getting anything like temporally relevant, but what was interesting is that it was like in terms of what is your neural activity most influenced by? So is it of the 3 features? Is it the type of stimuli you're looking at, the instructional set, or whether or not you had nicotine in your system? And it was actually number 1 by far was if you did like a dendrogram or hierarchy with MVPA results, it was like whether or not the drug was in your system. And then there was a giant like similarity jump. And then it was what the instructional set was, like what you're trying to pay attention to. In this case, it was I think it was like an immersion instruction set, like imagine yourself in the video versus like they said like a more reporter mindset, like look at it objectively. And then finally the last jump was what the actual stimuli was. So I thought that was interesting. It was like drugs, goals, and then what you're actually looking at would influence the pattern of activity.
So when you say neuroenhancement, this wasn't like any increase in performance, or it wasn't that kind of.
No, nicotine does improve your performance on. I skipped that part. Okay. There was a behavioral task I wasn't as part of. I forget what it is. It's some sort of attentional task, but you actually perform better with nicotine in your system. And what's interesting is based on our results too, it like helps organize visual activity behavior. So because I think we used to work with schizophrenic data sets, right, Morgan? Yeah. And like 90+% of them smoke, right? So it's like this self-dosing thing of like disorganized brain activity, and it helps them organize it and make it clear. So yeah, that was really interesting. But it actually makes them perform faster on some. I think it was like a SART task or something. They like their D prime and RTs would go up.
Okay.
Sustained attention reaction time task. Yeah.
Because Alex, who's one of the videographers here, and I don't know if he's still on, has looked at caffeine and gaming. So that's why I was kind of curious.
Oh, that's cool.
And what it would change. And but he had EEG and eye tracking, which I wonder what it would also do with your eye tracking measures. But I want to be cognizant of your time, So it's 7:30. Do you need to take off?
I'm getting a thing, but I think I still got maybe 10 more minutes. I can shut up and let you guys talk though.
Well, I wanted to at least get back to some of your questions.
Oh yeah.
Like, did we answer all of them? I mean, the EEG notebooks, depending on your headset, I don't know what Richard would say in terms of getting a, what's the easiest way to get a stream, like an LSL stream out, or it doesn't even have to be an LSL stream, right?
It's okay. I mean, I kind of hack something together. I mean, that's what, like
Gotcha.
in my video. Oh yeah, in the video thing. Yeah, it doesn't matter. I talk about that too. But yeah, I kind of hacked something together. It was pretty glitchy because I've never used async before, but I kind of had to use async because I was connecting to a
Python library.
What's that?
What's
yeah. Sorry, it's a Python library. Yeah. It lets you run parallel loops. Yeah.
Gotcha.
Cool. Bye. I think she's off already.
Yeah.
Yeah.
What do you want to do?
So Richard's with OpenBCI.
Oh yeah. That's really cool. I'm so sorry. I'm
a lowly software developer for a mostly hardware company.
That's awesome.
I just like my job is like to help people, and I love helping people. And actually, my background is in special education. I have a bachelor of science in SPED. I did about 4.5 years of music education. Also, I was all right at drums.
That's awesome. Yeah.
But I started whenever I completed my my special education degree. I was doing it with computers 90% of the time. I was tired of the paper. I didn't like worksheets. The program that we were in was like, we're going to train you to teach without using worksheets. Like bring stuff in, bring things from home and teach the kids. And so all these steps about learning, I learned from that side. And so I've been programming for a long time. So now I have a kind of like, there aren't many people that know machine learning that have spent so much time on educational psychology and practicing how you teach people things. And like reward system, like reinforcement learning, I'm like, that made perfect sense to me. Of course you want to reinforce at every step.
Yeah, actually one of the DARPA projects I worked on was trying to I was more interested in using EEG like single trial, and I guess that's one of my questions. But that was number 2. I don't
but what are you trying to do? So sorry.
Oh yeah, more technically. Yeah, I guess I was trying to capture from a eye tracker. I was trying to capture from the OpenBCI card, and I just kind of accept any jitter that's probably happening, and try to use other things to try to match the captures up later, and then present a real time metric.
What's the refresh rate on the eye tracker?
It's actually not that dissimilar from the EEG. It's about 125 hertz. It ends up being about 125. I mean, the problem is once I start running a bunch of things, it goes. I think it can get up to 250, but it ends up actually running at 125. In the video, that's what it was running at.
How many devices are on serial ports?
I guess just the 2.
Oh, 2 devices. Oh goodness.
The BCI and the eye tracker. They're both on USB.
That might be your trick right there, because having just the OpenBCI come through the serial port, it's like, it's okay, but I'm getting this other one. We're already aware of this. I don't know. Have you seen that we announced a new product, Omar?
Yeah, I think I'm on the email serve. Let me look on this link really fast.
I'll do a shameless plug right now in the chat.
No, absolutely.
I can't talk much about it. I think Joe or somebody more technical. I'm not privy to like. I'm not
Galia. Yeah.
But yeah, we know that there's value.
Omar, can I ask you about the single trial thing?
Oh, sorry.
Yes, please. I appreciate that.
Anyways, we know there's value in getting the
Sorry, I thought there was a gap there.
From the device. Are you there?
was I getting a question about the single trial?
Oh, sorry.
Yeah. What are you after? Like it sounded like you were you had a kind of a standard in mind, or you had some idea of what a good single trial level data quality would be. I don't know if you were getting that from EEG or fMRI or some like
EG,
research grade versus
yeah.
other systems. And the other thing is you mentioned like oddball on the fly, and it's funny you said that because I kind of had an answer to you kind of primed to go, which is like you can get a nice oddball auditory oddball ERP with about 2 minutes of data, but it sounded like that was too boring. It's a task for what you had in mind.
Yeah, well, in terms of, I mean, this is my I guess my overview of the whole neurotech field and the utility of it, and kind of where it's going and how much we can do non-invasively. I guess I'm simultaneously optimistic and frustrated a lot of times when I work with this stuff, because and maybe there's a flaw in the way I'm thinking about this, but my thinking is that really, in order to enable real applications, eventually what we really want is good single trial SNR. And in my mind, it's like 70% would be good, because maybe you sample 5 times.
You mean signal to noise ratio?
Or I'm sorry, classification accuracy. So at a single trial level, because and then on top of it, not really be interested in oddball things like that, because I mean, there might be applications we can think of, which I think if there are, that those are easier targets to try to develop towards. But like some of the DARPA work I was trying to do was to see how aggressive we could get with even splits in trial classes, and on top of it, really push the far by trying to not have people like respond to one set of them and not respond to the other. Like take away these things like oddball frequencies, these things that help produce a strong single trial ERP, and see what we can actually get. And a lot of times I think that really ends up putting us more in the science area, where we have to aggregate, at least 100 trials from people, and maybe even aggregate across participants. And so where we have like significant p-values, we'll often only have classification rates of like 50.5 or 51%. So at a single trial level, I haven't been able to like see like 54%, say, with like the best methods I can throw at this stuff. In again, with a non-oddball type and other features that I would think would be actually useful for
a single trial. That means how much training is involved. Like you get one try basically to get over 50%.
Well, so
I think it means basically you have you want to be able to do do a thing, right? Because you're really talking about kind of control context here, aren't you? You want to have let's say an image or whatever, but you want to be able to have a response to the visual input or the auditory input, the event, that is robust and reliable in real time. Right. I guess that's the motivation that you're getting at there, Omar.
Yeah. So another distinction I like to make is that I guess I'm not so much interested also in BCI, that is brain control of devices. I'm more interested in how your brain is processing things in real time. So like in my mind, if you could solve that, you could solve the single trial problem. You could solve like learning assistive loops, things where you're integrating a computer into, you're basically viewing things through your eyeballs, hitting your visual cortex. Something is seeing how it's hit, and maybe further upstream, and then the computer's processing how that's actually how you're processing the stimuli, and then maybe like reordering if you're doing flashcards or something really simple to more advanced applications. To me, this is like the future of actually how this stuff is useful and integrated.
Well,
and to me, this all ends up
John and Morgan, because they're all imaging in simulation. That's yeah.
So I was just curious what your guys' experience has been on the actual accuracies when you are kind of this severe, because I've been hitting a wall, and I assume it's the limitations, but maybe I'm doing something stupid.
Well, so I dropped a link.
Well, I think one area that's kind of a state of.
Go ahead, John.
Please.
We've got delays. Sorry. Go ahead, Melvin.
No, please, John. Go ahead.
Yeah. John,
Or-
go.
Oh, right. Well, SSVP speller type things, right? I think this is more, if Cristiano were here, like he's really one of the experts on that. But one of the task paradigms that delivers the best classification accuracy and best like real time performance is to use flickering, use SSVP type things in some spatial arrangement.
That's what Terrible did with their VR set.
Doing moving window like spectral feature detection rather than say like a block design, something that has some time domain variation. So like some things additionally you can build on top of an SSVP design that give you that give you more SNR while still allowing you to be working in real time, but you're kind of combining the features of like having a moving window and also the averaging that happens inherently when you're computing stuff in the Fourier domain over some window. So there's some kind of sweet spot there for real-time SNR that is like my understanding. This isn't something that I'm doing a lot on for those kind of designs when you can work with that kind of design, which is it's not everything you would want to do.
Yeah, it's interesting. I looked a lot at SSVP, but I realized I was using sort of the basic version of that for some of my experiments. I was familiar with the temporal ones, because that allows you to like CCA in the temporal domain, really basically. But the spatial, I'm trying to wrap my mind around that. I guess it's moving in space as you described, and then it's still flickering in some frequency.
Yeah, so you have these speller things, right? Where you have
I'm familiar with those.
On a screen, you have say
the grid of
that's what I meant on the spatial aspect.
Oh, I see. So you're selecting spatially. Right. See, but this stuff kind of this is where I kind of lose it, because it's like why wouldn't we just use eye tracking or something? I like what I'm more interested in. Yeah, you know what I'm saying. I mean, what I'm more interested in is more like and I know this might be overreaching, but to me this is where if we're looking at the long term, ideally it would be to process these things in very naturalistic environments, or at least on a screen that could be synchronized, that you could see your response to what you're looking at, and something obviously ideally too that's not terribly visually fatiguing like the SSVPs can be as well. So I like for instance, there are signals. I mean, I don't know if I'm selling anybody on this, but there's signals of like your familiarity versus novelty on there's EEG signals of that. So like if you're flipping through a lot of material in like flashcard format, in theory you could be psychometrically categorizing things they are more or less familiar with, and then that could be like an actual enabled loop. There's things like this that I don't think people are talking about, and I know it's probably because it's a little too ambitious.
I've been saying before with NeurotechX, if you could straight up make a test using positive and negative valence and determine if somebody's a racist if you just showed them the right images. You could make a test there, I'm sure. But then what happens with that data? And then they get blasted on Twitter like in Black Mirror.
Yeah, I'm not interested in Black Mirror applications. Yeah. So I don't know this. Sorry, John. I don't know if I got your intro. Where are you based, and what's your full name?
Yeah, sure. John Griffiths. I'm in Toronto.
Oh, cool.
And I'm an assistant professor at U of T, and I run a research group at a research hospital called CAMH, Center for Addiction and Mental Health. And we do like a combination of computational neuroscience and neuroimaging. And kind of part of that, but also something that's
You're
been
breaking up a little, John.
on the side, but I'm kind of bringing into the, sorry, something that's been, I was working as a kind of hobby project that I've kind of brought into the research program is the
That's a cool.
EEG notebooks. But the rationale around that is there are, like really, I think, important and useful applications of mobile consumer grade EEG in both research and the clinical domain. So we're kind of moving, we're trying various things out in that domain, and EEG notebooks is kind of a vehicle for some of that activity as well as other things. But I'm a bit like Morgan in these kind of calls. I'm like a neuroimaging person. We sometimes, go on long, winding conversations about imaging stuff.
Well, I mean,
my
it's cool because
background, at least.
You did mention you were going to give a application towards Cornell. I think that'd be really cool if there's neuroimaging people working on that stuff. Because
I just wanted to say that I dropped a link to the Mind Effect GitHub, and which is pretty much what the kind of stuff John was talking about in terms of they're implementing fast visual presentation or steady state VEP spellers and in Piglet, and then doing real-time processing using BrainFlow. So you can use any device that BrainFlow supports, which obviously includes OpenBCI. And this is their new open source release that they're going to talk about next week, and they are I mean it seems
I can do it with one of my Raspberry Pis.
No, you don't need that anymore.
Oh.
They're not tied to Raspberry Pi anymore. So this is their like new release since the Kickstarter that will is I mean I hate to compare them to EEG notebooks, but it's like EEG notebooks if instead of PsychoPi they're using Piglet directly, but I
don't know anything about Piglet. That'll be interesting to find out.
For these like specific BCI speller kind of applications where you're doing frequency tagging, I mean, you can kind of see why they would kind
Have you heard of this, Omar?
Say what?
Have you heard of Mind Effect?
I believe so. Yeah, their
device. I don't believe it had anything on the front. It was a headband, but it had them all in the back.
So
it's needed for SSVEP.
Exactly right. So that was the one thing that came up in Jason's conversation this morning was that they're just like NextMind, right?
Yeah, that's the one I'm thinking of. Yeah.
Okay, NextMind's the Paris based one. Yeah.
Some of your early I saw in your video that you tried some yourself, some headwear.
Oh yeah. Before I printed out the OpenBCI design, I was because I was trying to do. I don't know if
some of the cool stuff that people come up with is we knew we're just gonna ship the boards and people can design.
The Paris one. I forget what the Paris one is called, but because that always made sense to.
Yeah.
I was working on it a couple years ago because I was like, why isn't people that's where all your a lot of your relevant signal is if you're doing this stuff. So I made one and I packed a bunch of electrodes in, and but it was just easier to use the OpenBCI helmet after a while because I suck at 3D printing. I'm just so bad at it.
I was so scared when I put my set together. I saved money and got the assemble it yourself.
Oh my God, I did that. I'm never doing that again. The only thing
that'll really go bad on the Mark V is the little clips that hold the wires in. Since they're so small and they're 3D printed with corn plastic, the PLA, but they're also very easy to print and very cheap to print. So, and mine lasted like 3 years, and then I had to replace them.
and certainly one of the big things, one of the big pushes that we're trying to make with Moab, which I don't know if you're familiar with, which is the mother of all BCI benchmarks, which had historically had a kind of focus on motor imagery, but trying to add in a bunch of SSVEP data sets and and get at like what are the best classifiers to be using across a number of SSVEP data sets that will hopefully give us some better sense, or certainly benchmarks where we can be trying out new classifiers and getting these kind of real time. Sorry.
On that note, what did you use in your video? What metrics were you looking for, and can you provide any details? I'm not a machine learning expert, but if you could.
Yeah, I can run through that really quick. Just really fast though. First, I was going to say about Morgan, what he said about the Moab.
Yeah.
It's funny because I applied to ARL funding, which I mentioned, and I was trying to find EEG data sets online, and I have a few of them on my computer, and then eventually I kind of gave up and ended up collecting my own because I wanted a really large within participant, because I was going to do like neural network stuff, and try to do single trial neural network stuff, and but I remember trying to like convert these data sets and trying to figure out the timings, and I was losing my mind, but a lot of them are SSVP, which is fine. I just wanted the neural network stuff. You need like 10,000, 50,000. I mean, you need some crazy number really to work. So,
well, but there's another project, we had Arvind join us a couple months ago now, I think, right, John? But he was having this is what he did with some pretty small data sets, but using Keras and to really improve SSVP, SSVP data sets. And he's in he's in Ning Yang's group in Waterloo. And which is like has been publishing on these kinds of BCIs, just like Ziping Zheng at San Diego. And so I think he's using one of San Diego's data sets as his test, evaluation data set. And it's only like 12 subjects, It's it's not a lot of data.
No, I end up doing like a 2 or 3 subject, because that's, especially with the Corona thing, that's what I ended up using. But
right, okay. So this is recent.
One of them was recent. I don't know if to respond to both those things, which are both like what signal processing I used. I don't know if this is going to be more confusing than helpful, but basically with the here, I got the slide up. Wait, where's the share button? Okay, sorry guys.
Middle.
Got it.
So Aravind, the thing you just shared, Morgan, he was trying to increase SSPEP accuracy with different types of classification.
Yeah, so he was basically comparing a convolutional neural net classifier against like a CCA and like two variants of CCA, and showing a pretty dramatic a pretty good step increase in the accuracy.
Yeah. So I'm gonna have to go. Sorry, in like a minute or two. But really fast. Yeah, actually. So for this project, I actually ended up using different versions of convolutional neural networks. Cool. I actually tried single dimensional convolutional neural networks at sometimes too, but this one I ended up doing like a Fourier decomposition and then doing CNNs on that. And then to save the burden of trial that you need for CNNs, I ended up doing almost like a regularization procedure on the early weights of the CNN by simply looking at within my train, I had like a train test split, on my data set. And so within my train, I was looking at, so I don't think it was exactly this, but it was something like the like the D prime or the correlation or some metric like that between my two trial classifiers, or my two types of trials within each cell of the CNN. So anyway, so this was like the early weight maps of this project, and it was kind of cool because I actually ended up putting in unprocessed EEG data, and it ended up down weighting like the 60 hertz and down weighted the 0 hertz. So it was kind of cool. For the video project, I let me kill that
because
there.
it's present all the time, right?
Say what?
Because that noise is present all the time. So when it looks at a difference in the time domain, right, it's there. So
yeah, as long as your experiment is set up correctly. I mean, if you put all your trials up front and then put your second type of trials up later, in theory, you could see like some separation in like the 0 hertz or the 60 hertz, which is just a noise band basically.
So what were you looking for with the video, with the game and League of Legends or whatever?
Yeah. And that was the other thing.
For attention, or
sorry. They just told me I was too noisy. Okay. Yeah. So what I ended up doing was actually I used CCA on that, which is the other thing that you guys just mentioned. So what I did was, I denoised it with some pre-processing functions I created.
Did you post it on GitHub or just?
No, I didn't post it anywhere. Yeah, I was actually using. I was doing a CCA between eye movements and the EEG data and every part of the spectrum. So I was looking for a signal that was like event-related potentials. And in this is assuming that every time you move your eyes, you're getting a new like event processing. I mean, there's flaws of that because in theory you could be, internally ruminating and moving your eyes. You could be staring at one spot and the game could be changing. But so I think in the end, I tried a few things and this one worked pretty well actually, kind of surprisingly well. So I ended up using it, and I think in the end it was probably just looking at like the amount of visual attention I was spending on the game. So maybe when I was like kind of more spaced out and not really, my brain activity wasn't as correlated with my eye movement, I was probably just like internally distracted or tired or something. I'm not particularly good at this game, so it's probably a pretty basic metric, but yeah, that's what I was using. It was like a CCA measure between eye movement and EEG within each spectral domain, and then I had a model to weight which spectrums or which frequencies.
What's CCA?
A canonical correlation analysis.
Okay, let me Google that.
So I extracted eye movements, turned them into events, convolved them, and then end up CCAing that with each spectrum, with a like a short FFT window within each spectrum. So I had time series that were matched in samples.
Picking and choosing of machine learning. Are you doing that from what main packages are you using, or is it a lot?
It's all Python packages. So it's like, I guess, whatever CCA and regression you can get from like sklearn, I think, right?
Okay.
And then yeah, it's nothing more advanced, like more abstracted than that.
Oh, cool.
A PCA, I use PCA to basically clean the signal up. I use the head motion data. That's right. So the OpenBCI has the head motion thing. So I was trying to remove head motion artifacts using some PCA functions I wrote. I know like NeuroPipe has those functions, right? They have those really good like subspace artifact functions, but I just wrote my own.
If you want to rig it up, you can do external triggers. There's
I've used those. I use those for one of my experiments, and it causes it bleeds noise through all the channels. I can't fix that. Yeah, it's unfortunate.
They all have to be connected or something, and then the other pins have to be grounded out. I don't know.
Yeah.
Well, I'm certainly hoping that Tim or Christian can come talk to us about NeuroPipe.
Do they respond to anybody?
I don't know. I mean,
Yeah.
Tim's joined us. He's joined us at like in person when he was in San Francisco. But we will find out. I mean, it's not open source though, so
no.
It's. I mean, but I'm curious mainly just because they are the developers behind a bunch of other open source tools. But it would be cool to know what you're getting when you move to NeuroPipe. What was I going to? Oh, just that we're all the things that you're talking about. We've got in Moab, or are things that we can play with in Moab, but we can play against hopefully like 15 or 20 data sets, right? So that
as with Moab, it sounds like it could be a lot of fun for you, Omar.
Yeah, maybe. I told you I tried to use other data sets and I was spending hours trying to convert and chunk out events and stuff. And
this is why Moab's such a great community project, is that like it's one is getting data sets kind of prepared for it, and then the other is getting pipelines implemented in this framework. But it's like, but think of it as basically a very light layer on top of M&E and scikit-learn, right? I mean, it's really using those, but it's just saying like we need to kind of like have everything processed the same way or using the same conventions, so that everything you've got the data sets have an interface, and the pipelines know how to deal with that, and then you can look across, you can see CCA and a bunch of other classifiers, plus hopefully your new fancy one, and then see how that benchmarks against all those. And so some data sets, the problem being, as Arvind saw, like if you're only able to test against one data set, then obviously, you really still don't get at the generalizability of your algorithm.
Yeah, it sounds great. I mean, I hope that if that works. I'm gonna go now, but
take care.
I appreciate talking to you all and meeting you all.
Happy Thanksgiving.
Happy Thanksgiving to you all.
Have an old friendly face on Thanksgiving join us. So really awesome, a pleasure, and hope to see you more on Slack.
Yeah. Nice meeting you guys, Richard, John.
Take care.
Hey guys.
Nice to meet you, Omar. Yeah, thanks a lot for the presentation.
Yeah.
Yeah, thank you very much.
Wait,
Great.
You had attention? Or no, it was weird. He was said the specific answer he says was the correlation between the eyes and the EEG, I guess. Yeah, that's kind of complicated. I never would have thought of that.
Always better to have eye tracking.
Yeah. It is wonderful.
Yeah. So, I mean, just related to Moab, the NeurotechX Paris meeting Monday was the guest was Sylvain Chevalier, who's been managing the Moab project on GitHub, which was awesome, and things have gotten a little bit more settled for him in teaching and dealing with lockdown, teaching remotely and all the problems that COVID have created at universities. But so it was great because he's got a bunch of PRs that would actually add a bunch of features, including SSVP datasets and including what Rashik was going to add, or what we were going to try to document in terms of adding a new pipeline, which was adding CCA. But then, like, this was the great thing of being able to talk with him, is he was just like, hey, yeah, I've already got that. And then he was like, oh, wait, no, it's not. I haven't pushed that yet. And he's like, okay, yeah, now you can have that. And yeah, I mean, we, as well as like what to do about, a couple, following the kind of like quick start instructions, Moab, if you actually follow those, then you will get errors. And it was like, what can we do to move past these two particular problems that basically just relate to of the, I forget, 16 or 19 data sets that are included. There's issues with two of them that have nothing really to do with Moab. It's like, one is about like the FTP, get data function, and which I think is something that they were depending on M&E for, that doesn't work, and then accepting a GPL license with a web form that they can't do for you. And but it would be really great to get those issues removed, like basically just take out those data sets from those particular instructions at this point, just so that somebody who's new to the project can download it and can run unit tests and Moab run and not get errors. like that would be great. What else did we talk about? I mean, he also, one of those problematic data sets is the one that's an EEG FNIRS data set, and simultaneous. And so we talked about adding the, basically sucking in the FNIRS data as well, since, we looked over the M&E functions for processing FNIRS. And, and even if it's like at this point, just to say like, hey, we've got this data set in, like, because the main thing I see with FNIRS is that there is no big, there's no open neuro of FNIRS, and there's no, I don't know an equivalent list of publicly available FNIRS data sets that is longer than 2. And if anybody knows some, or if there's something like Mohit's EEG data sets GitHub list that we could know about, then I'd love to see that. It does kind of help for Moab if we could have a bunch of FNIRS that are also motor imagery, say, that like the original Moab data sets. But yeah, like I think I think just having any ERP, any event related FNIRS data sets would be awesome to include. So he loved that thought, and we can certainly grab it. It's just this particular site has a pop-up menu that requests that you tick a box to say you accept the GPL, because they release the data under GPL license. But I wonder about that, or like, I said, well, have you actually, gotten in touch with Berlin and asked them about that? Because, SPM is released under GPL, but you can, and, like EEG Lab, they like you to fill out a form. They report those numbers when they, go for new grants and things. but that doesn't mean that they wouldn't necessarily kick us a direct link that doesn't require that. Or certainly,
Hey, John, can I ask a EEG notebooks question related to that?
Please.
About you there?
Yeah.
Oh, okay, didn't see your screen move. Is it looking like they will let us release it later, or you just have to dance nicely around their requirements?
Oh, you mean the database item?
Yeah, they mentioned
You mean the thing they were saying about?
and something about
Yeah.
releasing this publicly.
Sorry, what's this?
I think that can be addressed. I mean, look, like you said, this was in the ethics. They had issues around database.
You need to clarify a bunch of things.
It was outside of the remit
Yeah.
of the REB, but I mean, really, we could say a database, but we could also just say stick stuff on Open Neuro. And again, if there's a lot hinging on the concept of a database, then we can just say, well, we'll just put it in a repository like you do normally with data when you're making open access, and there's no
right.
I mean, the
OSF,
the specific notion of a database that we care about is not like a particular hosted file. It's data that exists somewhere that can be pulled, and we don't really care where it exists and so on. And so yeah, I don't think that's an issue. That's one of these things that I'll reply to.
Okay,
that'll be all right on Touchwood.
Well, that had me a little worried. I was like, wait, does he? I guess he just needs to explain more. So, okay, I guess explain.
Yeah, because if you think about, I mean, it's to connect that to what Morgan was saying just now. In both respects, he was talking about code and he was talking about data, right? And just how Moab works, right? It fetches data from repositories, and the meaningful sense of a database from the point of view of this kind of open data analytics approach is not. It's not about there being a database that maintains the data in allocation. It's about there being a software layer that has fetchers that pull data from public repositories and integrate them in a useful way. You don't even want to be storing the data yourself, because it means you have to do hosting and you have to pay for storage and pay for bandwidth and stuff. That's not something that you're not going to want to be having to deal with. But the thing you need to focus on is providing the interaction layer. That's the meaningful contribution. So we
GitHub a standard now for that? Would they like GitHub? I mean,
well, not for the data. No. So for data, for neuroimaging, which EEG is within the broad definition of, Open Neuro is the emerging standard repository location. There are others. So there's this thing called NitrC, for example, NITRC, which has actually been around longer. That is another place that people kind of dump data sets, and even like Figshare and Dryad. There are other cross-disciplinary repositories for data, OSF as well. So there are a bunch of places, and GitHub, but GitHub isn't the best place to put data. It's not optimized for that. Other locations are more optimized for that. So we would go somewhere else first as a database storing location. There are several options. They're all free and maintained.
So, hey, John, following up on the Moab issues, so you don't have a problem enabling CI from GitHub? I mean, I forget
right, yeah, you're asking. So so we have this CI pull from Eric, and I haven't kind of made it fun. It's not going to do anything at this point because it doesn't push the docs. It builds them,
Yeah.
but it doesn't push them to the GH pages branch. So I was looking at it just now, and it's like, what would be involved in this? And I don't, you'd have to give it keys and access and stuff. So I need to look into what that. I mean, in terms of the actual code, I think it's just there's this command at the end that's make HTML, and that's just changed to make install. And make install does a push to GH pages, but in order to do that, you're going to have to give it SSH keys, and I don't know what's involved in that.
And is that maybe something that like the public NeurotechX GitHub members would automatically have access to that?
To what?
To the GH
file?
pages. No, to the GH pages. I mean, I'm just still, I mean,
well, everyone's got access to it.
Okay.
Everyone's got read access to it, but it's write access, right? It's push access.
That's what I'm talking about.
I think there's yeah. So but that's not, I don't know if that's part of her say. It should be easy to figure this out within a few hours. I just haven't got around to doing that yet.
No. I mean, I'm just trying to understand Sylvain's question to me, whereas like I need to get in touch with one of these five people.
All right, so yeah, so you need to find out. Basically, I think it was Yannick who gave me admin access.
Okay.
On EG notebooks, and if he doesn't have that on Moab, then that would be an issue. And you just look at collaborators and or whatever the tab in the repo, and you see who's on it and what access level they have. So it's easy to check. And yeah.
How do you? I mean, yeah.
It shouldn't be an issue.
Yeah. Well, I mean, I think Yannick's on it now.
What tab exactly you mean?
Yeah, I don't. It's funny because it's like I don't actually see where you can get at like who has what privileges.
It's settings and manage access.
Settings. Under Moab? All right, like under the project settings.
Yeah, in Moab, and then settings, and then manage access.
Wow.
Looks like John might have cut out for a sec.
No. I think John told me what I needed.
Morgan, I had a question for you
Sure.
about your conversation with Jason from Mind Effect.
Yes.
Because Chris did a kind of virtual introduction, and he was in facilitating discussion on this, which hopefully will happen soon. But you've already talked to him.
Yeah.
Right. So what have they done? Like what?
Sure.
Are they already? Is it just like an idea, or have they like written code and made things work already?
Yeah, so this is a software release, and like they're still working on some things. So unless like you can give me a really concrete thing, like I said something like so are you using PsychoPy? And they're like, Jason's like, no, we're using Piglet directly. And then when I said something like, well, we use PsychoPy with EEG notebooks, and he's like, well, we've got an example that uses PsychoPy. And I was like, okay, so it's not, again, it's the kind of thing where it's just like, what they've definitely got is a release that's like separate from Raspberry, is using BrainFlow, so it's open to other headsets. And
Hey, Morgan, what's Piglet? Is that a Python library for something?
Yeah, it's an OpenGL. It's an OpenGL library.
Wait, OpenGL is visuals.
Yes, so these are like BCI spellers or visual apps.
Man, you really need to have a good drawing app if you're going to do SSVEP. I found that out with Process, because if you can't guarantee 30 frames a second, your flashes aren't going to be right for 15 for 2 flashes every other frame.
Yep. So this is why people. I mean, this was Jonathan Pierce's kind of like motivation to start PsychoPy, which was like, hey, I need low level access, with super tight timing control.
Before.
Yeah, I mean, historically there was a project called the Psychophysics Toolbox that was MATLAB based. It was MATLAB and C based. And it was what all the visual psychophysics people used, and like I said, there was a lot of C, so that they could have a lot of really tight timing control. But there was also a lot of using OpenGL features to basically control the graphics card in an appropriate appropriate fashion, and is like a Python version of that is what PsychoPy started as, and yeah, so like you said, like trying to do so Unity with WebGL,
That's what's over there behind me is the Unity OpenBCI Pong game. And so thankfully I jammed on it for a day and got a main menu. So now you can select, hey, I want to play without any gear. You can just play for fun. But that's why I'm so interested in when Ryan gave the crash course in game design, that I just need to look at that chart of the narrative and then do that for each level and then that for the whole thing. Yeah, I think Ryan, he says, I hope it's fixed. Yeah, it doesn't work. And I found an issue, and it's kind of lame. But I was told, hey, with the new headset coming out, maybe try to make it VR compatible and for Windows. No stress to make a thing. But what I'm going to have to do on that project is add multiplayer.
Yeah. Yeah, I hope that it supports this headset that I can.
The idea is that we can make it fit.
Yeah,
Try a little with minimal effort. So they've tried to make it so that, and what you see on the website is that minus a headset.
One nice thing is that the faceplate comes off. So as long as you get the faceplate to somewhat match this, it will fit on here.
Oh, yeah. They've been working on the face pads. Making them comfortable and making them look good.
Yeah.
They had to fit sensors inside the face pad.
Yeah, I know. When I saw that, like, I still have like 5 or 6 questions.
Look, that means you're getting, I think you're getting, I'm not going to say exactly, but you're getting a host of sisters right over here above these beautiful cheek muscles.
Yeah, I'm guessing
I'm sure you can detect a smile just with the EMG.
Oh yeah, I'm guessing some of those are probably some of those are the EMG sensors. And
I did an example and posted it on socials. I think she just did that and like had an emoji above her head. Changed the emoji based on what face she was doing. Cool little example.
Yeah, and I'm hopeful that Unity fixes a couple of its issues, but that they're working hard. Like I been looking into some of the new Unity.
Like what
They
would
have new frameworks like HDRP and stuff for high dynamic range, like high resolution.
Hey Ryan, how much Unity work have you done? Would you be able to code review my stuff?
I can do a bit of code review. I generally do a lot more of the like game design in terms of like visual story and like level and UI, but I'm okay at code review. I can usually help find faults in code.
Yeah, I don't want to break any Unity no-nos or C# no-nos, really, because
Yeah.
I'm coming from mostly a Java perspective. But
Yeah. Still, also Alex Peak, he'd know dancers very quickly. Though also we're still both learning the new dots framework, and I'm also learning.
I started. This was an example like from Unity themselves with Pong. So
Yeah.
what would the
But
level design look like in Pong, though? That was my next question.
I mean, Pong in VR, there's a couple ways people have done that so far.
I guess
That
you
have
can have
been,
5 levels. I don't know what they would be.
yeah. I
Maybe the amount of control that you have to do, like neuroplasticity, adapting to the sensors based on what you see. Like at first you're not going to do it, but maybe after a while you train your brain to do something.
Yeah, like if you can add a new
Maybe we're gonna have to
dimension of
require it.
control
Yeah.
each level, like
Should
in
they be
essence,
harder or just be easy the whole time?
it would get harder. I mean, you could break it up into like both speed, so you get faster at control, but also have levels where it's 2D Pong versus 3D Pong, where you have to like move the paddle in just left to right, or left right up down, or left right up down forward.
I think I
Or
could use the example and then just slightly shift it a little bit.
yeah,
Look,
like
here's what I imagine. Like you take away the walls at the top, and then you have to do left or right, and that moves all of the paddles on all 4 walls, and you have to keep it in the box.
okay, that would be pretty fun, because yeah, you could go up to like I think
Because you can
8
already make single
dimensions.
player Pong and move them both like this at the same time.
Yeah, but then also picture if like you're in some sort of weird gravity, so stuff starts rotating. Like
It does a curveball.
yeah. So you have to like move the paddle. Like there's this like I like Block Breaker more than I like Pong, and I love 3D Block Breaker
I wish
games.
someone would sponsor this. This sounds like a lot of work.
Yeah, I mean, one of my friends, he made like a 5-dimensional VR chess game recently where you can actually change your past moves. Like it's really confusing, and yeah.
And so here's the control methods I have so far in mind: keyboard, mouse, and I want the mouse to work on like I guess touchscreen doesn't matter. I guess it just needs to work in VR. I'll figure that out later. Touch the keyboard, mouse, the accelerometer. If you want to just hold an OpenBCI board,
Yeah.
rotate it like this for fun. That's kind of
Yeah.
cool.
If you want to test,
And then focus. We're gonna
Yeah.
use, I can use the BrainFlow metrics straight from BrainFlow. It figures it out in a little sub process, and then you just pull it in. We're gonna try to bring back the focus widget soon. I just made an issue for it. So
yeah.
woo.
If you want to test accelerometer as a control thing, I'd recommend getting a PlayStation 4 or PS5 controller, because those have built-in gyroscopes and accelerometers. Oh, nice. Okay.
Yeah,
Yes.
I meant before you want to play before you get connected, or you just want to play like this. You turn on the board and you do like that.
Yeah. I'm trying to remember, and I remember some of these old handheld things. Like was it 20 questions where like there was electric version of 20 questions where you shake the ball a certain way and it will reset. It was fun.
Cool. Well, thanks. I think I have I never studied game design. I've seen books on it. I know it's a serious thing. So thanks
It's a lot of
that
fun.
graph and then I'll try to do what you said, basically.
Yeah, or I can give you a link to, there's a free version of one of the main textbooks we all use that has a little chapter about like player interaction and how to like control how much they're interacting, because another thing about game design is just like any workout, when they mean rest, they literally mean you need to stop controlling the character for an amount of time because you can strain your body, which
So that's
not
another
good.
factor of when they decide to do a cutscene.
Yeah, and also how cutscenes are done. Like, they're a lot better now. They're much more diegetic
Have
than
you
they
heard of
used
the
to
game
be.
Super Meat Boy?
Oh yeah, I have.
I love to
Super
see
Meat Boy.
somebody use Super Meat Boy in a study. It's a lot harder than Mario.
Oh yeah,
Got anything with Mario, Morgan, that you've heard of? It's an MP hard game. It's worth studying.
Sorry. There's a lot of games that meet that criteria. But sorry, what I was zoning off on some EEG app that I was. It looks really interesting, but I'm unable to build. And I think it actually relates, John, to something that I think we should add. You know, like working with a couple of the students on EEG notebooks. I think it might be the point where we need to add to the Conda create, like not only add Python, but like add like Python equals 3.7 or something like that. Like it's automatically
yes, I'm aware that.
Yeah,
I think depending on what OS you're on, because I think if you're in a Windows Mini Conda terminal, then it kind of understands more of the Python environment than if you're running in a terminal from somewhere else and you're just kind of pointing to the Conda binary. I've noticed this, and yeah, so I think we want to add Python equals 3.6 at the end. Would you agree?
Or 3.6, yeah. It's coming up. I mean, it's funny because I dropped a link to this JHU app for EEG, but it's relevant only because like this is failing on my Linux system just because I did a Conda create with like I'm getting 3.9 now, right? And because of the requirements.txt is setting particular versions, right? And basically I'm getting errors because it's like, it's going, oh, I have no, there's no, I forget what it is, like, matplotlib 3.1.3 for 3.9, right? It's like, I'm not sure if this is an example, but it's like, but you know what you can imagine, right? And so
we definitely need the supported Python version. It's a shame that 3.9 has already started breaking things.
Yeah,
3.6 and
Yeah, yeah.
I mean, that was like 2 months ago or something.
It seems like it was this
Are
year.
you talking about running this
Yeah.
on a computer or like GitHub Actions?
It was recent.
Yeah. So sorry, what was the question, Richard?
Are y'all talking about running?
Yes, I think I will do exactly that. I will put 3.6 as in
Yeah.
the Conda installation instruction.
What I realized in
Yeah.
talking to these different students, right, is that like they were getting like basically whatever Conda version they had, and then it was installing whatever that Python version, the most recent Python version, and even like two people who kind of think that they're doing the same thing are getting very different. I mean, even though they were also having problems where it was just like, it was basically like paths problems, whereas like they were pip installing in their environment, but they were still using base Python, right? So that's one problem. But like they were hand installing some of the requirements because they were like, oh, but when I pip install requirements, it fails. And I was like, well, can you tell me what's failing? It's like dumb things that are like just not available on 3.9 now, and in this particular case, I know what it was. It was Torch. So it was Torch, which is a particularly difficult one, right? Torch is a difficult one just because it's like GPU, not for EG.
Who's depending on Torch?
No. The app that I dropped in the app that I dropped in chat. Sorry. don't you use PyTorch? No. Right. So I
would know, and I'm glad that.
Yeah. Does your Python does Python issue? I forget. Does Python have LTSP's long-term support builds of old versions? Like, is there a single version of Python 3.6 you guys can point to? Because I'm just thinking about, like, we have that same issue in Unity or Blender or any program where it gets consistent updates that break previous work.
Well, I mean, like whether you're in Conda or whether you're, using like a python.org installer, when you install, if you get 3.6.1, like that's the same binary. There's stuff that definitely, like it goes out, they tell us in advance, like these things are going to break. And obviously there was the recent, move to 3.
Dropped, didn't it?
What's that?
Did 2.7 finally get dropped, I think?
Yeah. So like 2.7 finally got dropped. And
I was trying to use 3.7. I didn't even 3.9. I didn't even hear about this.
Yeah, there was much, pulling hair and
really
gnashing of teeth, or I forget.
October.
Yeah, it wasn't that long.
Breaking of programming.
Or have y'all tried EEG notebooks on 3.0?
I'm not aware of a long-term build. I mean, I know what you mean. That's what Linux is, right? Or
yeah,
Ubuntu,
Linux
at least,
has.
You have these long-term versions.
Yeah,
But no, I don't think there's a Python equivalent of that. I've seen it stated explicitly.
You ready for this? 3.9, the installer now actively disallows installation on Windows 7. For the same reason we don't build, Andre says we don't build BrainFlow on Windows 7 because Microsoft is no longer supports it.
Yeah.
I honestly had, and I'm not upset about this, I'd honestly forgot Windows 7 existed.
Yeah, I mean,
no, I swear.
My other computers on Windows 8.1 custom, like I have customized Windows 8.1 so far.
I know of many more systems that still depend on Windows 95 than
yeah.
Windows 7.
yeah. It's
In a lab
kind of like
somewhere,
there's this
to the internet?
giant gap.
Um, uh, so 20 minutes coming up. Well, so yeah, is anybody else signed up, or
Sorry, Morgan. Before you move on,
yeah, go.
I kind of wanted to just finish up the question that I asked before, but the conversation kind of moved on about
Mind effect?
the mind effect.
Sure.
Yeah. So what's the intersection with mind effect and EEG notebooks? That's what I want to know. Like what? So Chris is connecting me and Jason. It sounds like they've been having discussions about it. I don't know enough about the mind effect. I've been looking at the code, but I haven't run it yet. But it sounded like they'd already discussed like doing bringing it in and having a mind effect BCI as a EEG notebooks experiment or something like that. Like, do you have an idea of what that would be? And also, is their stuff all real time?
Yeah.
Or is it offline?
It's trying to be real time. So this is what
Right.
this is like certainly the easy overlap I saw was like using a mind effect experiment, with notebooks, and I think, I mean, the only kind of like, they don't support Muse, and partly that's just because they would need, they would need the auxiliary channel to support Muse, because all of their algorithms are basically looking for kind of steady state Veeps, right? So this is why they're using a headband with electrodes at the back, right?
I've never tried to do SSVP with the Muse, but without the extra electrodes, I don't know if it's good or bad.
I want to say like Alexander describes like trying it without and still getting something. but I think in general, that's like considered a bad idea. I mean, I talked to Jason today about like, I passed on some of the face processing stuff in terms of like, you could do steady state, face images in this kind of fastball way. And then you wouldn't need those back, these electrodes back here, and these electrodes back here, like basically require, this is tough to do without some sort of, elastic or, headset. Neurosity doesn't try and get electrodes back here, for instance, anyway, all of their stuff, because I mean, with the brain flow, like they're basically brain flow and notebooks already, right? It's just that their experiments have been more real time, do something during our experiment, as opposed to EEG notebooks, which is doing the traditional ERP thing, which is just like recording the events, say, that are actually coming from the experiment, right? And just recording the data for later processing. So yeah, I mean, it wasn't so much like,
Yeah, okay, that's
they
helpful.
needed, like I don't know what they would necessarily find useful that they haven't already done, but they're as you can tell, they're kind of like focused on a subset of EEG experiments, these kind of real time, these more BCI like kind of paradigms, right? like spellers. And definitely like have the algorithm do something in semi real time. Like I don't know what kind of latency they're trying to push, but then definitely like now turn on a light bulb or something like that.
Cool. I like the read.
They must be also recording the data and organizing it
I
like into epochs and so on.
I would guess 15 minutes. Okay, one sec.
Yeah, well, it looks like a cool thing. It's been well. I'll know more when I talk to Jason directly. Cristiano was saying that Jason wants to write a thing for the blog, for their blog about this, which is cool. But we need to kind of do it first before we write something about it. And we'll know more when we talk, I guess. I should probably play with Mind Effect as well.
Yeah, I'm excited for. I want to start trying some of that stuff out once I get a EG headset of some sort, or can finally borrow one of the muses. Though I really want to. I am just going to hope that the SF Neurotech can get one of the Galea to play around with. I want to just start recording a ton of data with that while in VR. I'm sad my headset doesn't have eye tracking, but if need be, I'll figure out how to mount eye tracking, because
I can either confirm or deny anything related to that.
that's fine. That's fine. Just like I'll later like
considered it. I can
Yeah.
say that it. I mean, they're not like not thinking about eye tracking. Eye tracking in VR is really appropriate.
yeah. I mean,
Actually, eye tracking in XR, all the different bodies is important.
Yeah, like the couple times I've seen it properly done.
EMG just on the corner of the eyes gives you a lot of data.
Oh yeah, that too. That's
excuse me.
Like
EMG, I'm sorry, EMG on the corner of the eyes.
Yeah, like being and like the different muscle. Yeah, so if those are EMG, those could definitely. I don't know what. You'd be able to see
and EMG, and then for sure that somebody hit their eye, and
because
how much pressure they used.
Yeah, you can. Then I don't know what triggers faster. Because you'd be able to predict where their eye is moving, probably from the MG. After enough time, and the focus of the eye from the eye tracking, like
people can test these things out with a Cyton or a ganglion right now. You just up and you're in business. So we know it's really possible. I think I asked about it once with one of our technical people, and they said like it requires a little bit of calibration. But doesn't a regular eye tracker require some calibration?
Oh yeah. Every time I've tried eye trackers, I mainly tried Toby at different events and Alex's Toby system with EG, and you just go through looking at a certain number of things over a couple of times till it is able to follow your eyes. It takes like between 10 and 30 seconds. And in VR, it would probably be a bit more complex since it has to guess a bit more about your focal distance with certain things, but it can be much more accurate. And
Here's what I've been holding back saying the whole time, because we talk about flow. The guy wanted to talk about flow. I think in the end, it's going to require a lot of different sensors. And then for each type of sensor, there's this certain modality that we get 80% accuracy on. And then we use that, like FNIRS in a certain spot, looking for one type of emotion.
Yeah.
And then we realize that it doesn't really work anywhere else in the brain. You get that impression, Morgan and John? Maybe the device 100 years from now has a little bit of everything, and it's using each different type of sensor for what it's best at, and that alone.
Well, certainly that's what.
Well, that's one thing that the kernel device could be good for.
That's why I asked, are they going to sell the individual modules? I mean,
if you
throw that on.
So there's much more like spatial localization in fMRI than there is in EEG, right? So if you're talking about like finding a specific brain region that's specifically responding to something, that's easier. There's more of a kind of track record on that with things like fusiform face area or particular parts of the visual system. I mean, there's not a million things, but there are particular parts of sensory systems. Also, subcortical structures you can kind of get quite focal responses for, but kernel can't measure from those.
Use implants.
But insofar as there's a little bit more of that regional activity in a kind of fMRI-like signal with an fMRI-like spatial resolution, then maybe there's more to come from kernel than what you've been getting from EEG so far. But that's still just an empirical question really at this point, and I don't know what its spatial resolution actually is.
So,
but look, I'm saying FNIRS look for something, then the EEG like confirms that, and then you maybe have an implant which is trying to get signals from deeper down, but you use those other modalities just to get from the surface.
Yeah, I definitely think implants could be really cool, especially like
if you get right back here and
possibly of like having different layers of implants, like a very tiny implant very deep in the brain, then more as you go further out, and they all communicate with each other.
That sounds hard.
Yeah, that like the amount of like brain surgery required for this type of stuff is going to be really, really high. Or we have to figure out some much more complex like frequencies.
Everybody wearing EEG devices at concerts. Nobody wants to pay for that right now yet. They barely.
So
yeah.
I'm gonna have to go very, very soon. Just want to wrap up with what's coming next week. We've talked about Brain Hack Global, and like I said, catch or if you're available, the NeurotechX Amsterdam meetup. And like, Jason, he was gonna come talk December 3rd, basically next week's hack night. But, he's like, so what time is that? I was like, well, for you, it would be 4 a.m. And he was like, I'm not going to do that.
Well, that's good for me because I'm in the middle of some.
Yeah. You're right.
During that time as well.
We won't see you next week, huh? But can we drop into? Can we drop into?
Maybe I'll check in. I'll say it's a maybe.
Can we check in with you? Or like in the sense of like, will there be activities? Yeah. Will there be activities that evening, this late?
Well, yeah. Hang about. So this is the thing. I believe the social is just before that. Well, hang about. Brainhack Virtual Social is 6 to 8 p.m. EST on Thursday the 3rd.
Okay.
So, yeah, I have a conflict there, but I guess I might be able to drop in here afterwards.
Sure.
Depending on how other things are going.
Well, it's I mean that's East Coast time, right? 6 to 8.
Yes. Yeah, so that would be. I mean, oh right, yeah. So that's earlier than
Which
we normally do here.
means
Right. So that's
which
not.
means
It's not a
that
conflict.
we can
Right,
we,
yeah,
we can
actually.
join. I mean, I can join the social
Hey.
before for sure. And
Yeah.
There's this Neurotech meeting that's starting next week, and a bunch of people from NeurotechX, like anybody who makes a headset is talking at this, and again, you can find links, and of course the Joseph Bacone, TUH, the big TUH meeting is next week. The IEEE Signal Processing and Medicine Biology Symposium, where the top placed Neureka Challenge teams will be presenting, actually presenting their work. So I'm really looking forward to that, to see, I'm hoping that in addition to presenting their work, we'll also get, working pipelines or trained nets. And well, I would certainly be following Maine to see what EEG NIRS or, other relevant NTX speakers and events that are associated with the Montreal meeting. That's December 1st to the 3rd. Yeah, that's looking like it's going to be a lot going on. Well, I put a link to, also somebody's going to be talking about anesthesia, which again, I still would love to get us a speaker, an anesthesiologist speaker, to talk about bispectral index and if that is meaningful at all. But that's it for this week. Again, happy Thanksgiving, everyone. Glad you could join us. I'm going to move on to, we've got a lot of pie here.
Yeah.
And
Yeah.
okay. Yeah. And I forget, well, not that you are Canadian, but like Thanksgiving is a month earlier in Canada. When was I forget.
Yeah, it was a month ago or something.
Something like
I forget the exact date, and I'm not like naturalized enough to